LTE MAC Lab is a system-level simulation tool running under MATLAB environment. The simulation tool has been used extensively within two EU7 framework program projects, 5G Now and Solder. In widely cited 5G Now, LTE MAC Lab helped to model and design a MAC layer of a new 5G system. In Solder project, LTE MAC Lab was used for testing various scheduling algorithms, later implemented in eNodeB scheduler supporting important Release 10 feature, carrier aggregation. LTE MAC Lab truly reflects the dynamic behavior of an LTE RAN focusing on radio resource management issues. It implements features such as scheduling, handover, and link adaptation, together with various propagation, path loss, shadowing and multipath, and mobility models. LTE MAC Lab allows users to analyze performance of LTE RAN and understand the dynamic mechanisms of the radio interface, including support for heterogeneous networks and carrier aggregation. Where can we use LTE MAC Lab? It has plenty of use cases, and here are the most important ones: test and development of scheduling algorithms, visualization of LTE network performance, network planning with HetNet eNodeBs, modeling the impact of carrier aggregation and HetNets on the user-perceived quality. LTE MAC Lab has a well-defined modular architecture. Let us start with introducing LTE MAC Lab configuration module, which is also equivalent to the first activity when the tool is running. Using configuration, we define network and set its parameters, which is later taken into account by next modules, including large-scale propagation models, which reflect propagation of the radio signal, mobility models, which are responsible for updating positions of the terminals, UEs, which keep context of the terminals, small-scale propagation models, which reflect channel fading, interference model, which maps current radio conditions to SINR values, eNodeBs parameters, which store current state of all the base stations, radio resource management module, which is the heart of LTE MAC Lab, responsible for such functionalities like scheduling, handovers, and link adaptation. Transmission and reception, which, based on PHY abstraction layer, decides if transmission was successful or not. Statistical data, transmission reports, which gathers snapshots of the simulation for post-processing and result analysis. The architecture is reflected by the structure of the directories and relations between files. LTE MAC Lab is delivered as a toolbox operating under MATLAB environment. It consists of M, MEX, and P files. Substantial parts of the code are open for the user's modification. Built-in help for each function allows you to see description for each function, get the references, check input and output data, and get the example usage of particular function. All functions have well-defined interfaces with described parameters, which makes it possible to replace them with proprietary customers' implementation. LTE MAC Lab can be used to simulate various simulation scenarios. As an example, we depict the basic case, which corresponds to a 3GPP Release 8 with a single carrier environment. LTE MAC Lab allows you to simulate networks compliant with 3GPP Release 10. Using carrier aggregation technique, it is possible to combine carriers and extend bandwidth. Release 10 introduced aggregation of two carriers in specific bands. Our tool gives you more freedom than that. It allows you to aggregate up to 5 component carriers and extend bandwidth to 100 MHz in any bands. This way, you can preview how network might look like in future releases. Apart from carrier aggregation, you can define heterogeneous network. Under macro-based station layer, you can add small cell layer, which can meet high user density demands and cover areas with low signal-to-noise ratio from macro-based station. Nothing stops you from combining these two techniques and verifying how carrier aggregation and HetNets can work together. Let's run a basic simulation with one base station and one carrier to see how the tool works. Features like multi-cell environment or carrier aggregation will be presented in separate videos. Simulation starts with defining input parameters. They are gathered into the following groups: main simulation parameters, environment parameters, UE parameters, eNode base parameters. Based on the default simulation parameters, we can easily create design scenarios and analyze their results. Simulation progress is displayed in the command window. When simulation is finished, you can process gathered statistics and display results as you want. Let's take a look at the cumulative distribution function of the base station's throughput and received power map. Received power is highest in eNode B position and decreases with the distance. Based on the throughput plot, you can analyze performance of the base station. So, what can LTE MAC Lab do for you? If you are a researcher, this powerful tool can significantly shorten your time to paper. If you are an engineer, LTE MAC Lab can reduce the risk of developing new products by providing reliable simulations. If you are an analyst, you can easily visualize complex network performance parameters in order to use them later in your reports. As you can see, using LTE MAC Lab is easy. You can analyze network behavior and performance without developing your own simulation environment. Just define the network structure and parameters and get the results. For more information, please visit www.is-wireless.com/LTE-MAC-Lab.